Welcome to the Agile Engineering Deep Dive. My name is Alessandro Guida, and in this episode I want to challenge a belief many organizations quietly rely on. That legacy software is something to escape from. In many companies, legacy systems are seen as old, fragile, and in the way of innovation. Something to tolerate until it can be replaced. At first, this mindset feels reasonable. New development gets attention. Innovation moves fast. But over time, neglecting legacy systems creates a different kind of risk. Not technical fragility alone, but organizational and financial fragility. In this episode, we'll explore why legacy software is often the backbone of the business, not a burden, and why managing it is a leadership responsibility, not an engineering inconvenience. We'll look at how undocumented systems, missing tests, accumulated technical debt, and compliance constraints quietly increase risk, and how incremental modernization and professional engineering practices can turn legacy from liability into a managed asset. This is not an argument against innovation. It's an argument for stability, responsibility, and long-term value. Because in the end, innovation only creates lasting value when it is built on stability. Let's dive in.
Welcome to the Deep Dive. Today, we are wading into a topic that, well, it probably causes a collective groan in engineering teams everywhere. Legacy software. We've all seen it. Unless your company was literally founded yesterday, there's a core system somewhere running something essential. And the code is, well, it's older than the new hires, and every time it comes up in a meeting, you can just feel the energy leave the room. And this isn't just an annoyance, it's a serious business risk, and frankly, it's a talent killer. I mean, we saw that in the 2024 survey you sent over, where something like, what was it, 58% of senior developers said they were thinking about quitting?
58%. And it was specifically because they felt their tech stacks were inadequate or, and this was their word, embarrassing.
Embarrassing. That's a powerful word.
It is. But that frustration, as real as it is, it's only one side of the coin. Because the other side is that those same systems are often the absolute financial cornerstone of the company.
The things that actually make the money.
The things that make all the money. They process revenue, they manage customer data, they keep you compliant. They are literally the engine that pays for all the new, shiny innovation everyone wants to work on. So you've got this tension. The engineers are heading for the door, but the business can't survive without this code. And that tells you the problem isn't really about code. Our deep dive today is centered on this idea that these undocumented, half-forgotten systems, they're not an engineering problem, they're a leadership problem.
A leadership problem.
Absolutely. The mission here is to figure out how we move from, frantic temporary fixes to managing legacy as a real strategic responsibility.
Okay, let's unpack that. I mean, we all throw around the term legacy code, but for a leader listening to this, what's the actual difference between code that's just old and the kind of legacy code that creates all this friction you're talking about?
That's the perfect question, because age isn't really the issue. Friction is. Legacy is any code where the cost and risk of change has become disproportionately high. And that friction, it usually comes from a mix of, let's say, 6 major categories.
Okay.
The first and the most common one is just lost or missing documentation. The system works, but nobody knows why it works. The knowledge is all in the heads of maybe 2 or 3 people.
And if they leave?
If they leave, you're in a world of trouble, which ties right into the second issue, obsolete tools and infrastructure. The system was built with a compiler that's a decade old, on a server that's no longer supported. The whole thing is a house of cards.
Right. So you've got a hardware risk, but what about the software side?
Well, that's the third factor. A total lack of automated testing. There's no safety net. The only test is institutional memory. That one person who knows, don't touch line 42 of the invoicing module or everything breaks. Every change is a manual high-stakes gamble.
And without that safety net, that's where you see unmanaged technical debt just explode, right?
Yeah. It just goes nonlinear. Tech debt isn't just messy code. It's years of shortcuts and deferred cleanups all piled on top of each other until making a tiny one-line change requires weeks of effort because the whole system just resists it.
Okay, so those are the internal problems. What about the things that lock a system in place from the outside?
Yeah, the external handcuffs. The first is complex integrations. The system is so tangled up with, say, a customer's workflow or a partner's API that you can't change anything without causing a domino effect.
And the last one, I'm guessing, is regulation.
Exactly. Regulatory or compliance constraints. In finance or healthcare, you might make a tiny code change, and suddenly you've triggered a full $1 million recertification process. When you put all 6 of those together, you start to see why this is such a tough problem.
It really paints a picture.
Yeah.
And it explains why so many organizations fall into what you call the superhero model, that one engineer who just swoops in and saves the day every time it breaks. Why is relying on that hero so dangerous?
Because it's a huge structural risk that's masquerading as a solution. You're basically taking out an insurance policy on one person. And if that person gets sick, or wins the lottery, or just burns out from the pressure,
Which they probably will.
they almost always do, and then that risk becomes a full-blown financial catastrophe overnight. So it's really on management, it's their job to make sure these systems aren't a ticking time bomb. And just as important, to make sure the new systems we're building today don't become the exact same problem 10 years from now.
So if these systems are the financial cornerstone, how do leaders actually communicate that value? I mean, all the celebrations are for new product launches, right? The maintenance work is always done in the shadows.
It is, and that's a cultural failure. Leaders have to actively celebrate stability. The best historical example of this is the year 2000 bug, Y2K.
Of course.
For years, you had these maintenance teams working on ancient COBOL and Fortran systems.
Wow.
Totally ignored. And then suddenly, this tiny detail about how dates were handled threatened to shut down banks, power grids, everything.
And those ignored engineers became the most important people on the planet.
Now we're heroes. But you can't wait for a near catastrophe to value this work. The lesson from Y2K is that this software is the literal backbone of our economy. When it runs smoothly, when it stays compliant, when it processes billions in revenue without a hitch, that is a massive business success.
You celebrate it.
You celebrate it. Leaders have to talk about stability and customer retention with the same pride and excitement as they talk about innovation, because a stable system is a huge, if unsexy, competitive advantage.
That reframing is so important. Okay, so let's get practical. If a leader wants to shift the culture from avoidance to, strategic necessity, what are the first steps? How do you make working on legacy code a viable career path?
Rule number 1 is simple. It cannot be a career dead end. You have to build structures for growth. The easiest win is implementing rotations.
So moving people between teams.
Exactly. A 70-30 split works really well. A developer spends most of their time on modern, new stuff, keeping their skills sharp, but then they spend 30% of their time working on the core legacy system. It spreads knowledge and it keeps people engaged.
That makes sense for the people. But what about making the old system itself better?
That's the second piece. You focus on modernization inside the legacy. This doesn't mean a big, risky rewrite. It means bringing modern practices to the old code.
Like what?
Setting up a real CI/CD pipeline, adding automated testing, maybe building a modern API gateway in front of the old system. These are all high-value, modern skills that people can build while still working on the core product.
And the experts, the people who already know the system inside and out.
You formalize their role. You create prestigious mentorship roles. They aren't just bug fixers. They are the official knowledge custodians. You recognize their value and you use them to train everyone else. It makes them a corporate asset, not a single point of failure.
That single point of failure is terrifying. So beyond mentorship, what are the big organizational moves to reduce that dependency risk?
It all comes down to strategic knowledge sharing. It has to move from a nice-to-have to something you mandate and budget for. You require pair programming on the trickiest legacy bugs. The goal isn't just fixing the bug, it's the real-time knowledge transfer.
Right.
And you create communities of practice for the maintainers. These folks are often isolated because their tech is so unique. Bringing them together lets them share ideas and honestly just feel less alone.
I can already hear the objection from a manager, though. It's too expensive to pull my best engineers off new features to train them on this old junk. How do you push back on that?
You push back with a simple risk analysis. You ask them, okay, what's the cost if the system goes down for an hour a day?
Yeah.
The lost revenue, the compliance fines. You quantify that number, and it's always a massive, scary number.
A company-killing number sometimes.
Absolutely. And then you compare that potential catastrophe to the small, predictable cost of training a few people and rotating them. It's not an expense. It's an investment in risk mitigation. You're trading a potential disaster for a controlled cost.
That's a powerful way to frame it. Okay, so For a leader who's listening and is convinced they're ready to act now, what's the 90-day secure playbook? The first few moves to lower risk right away.
The 90-day plan is all about getting control. First, get the code into Git or any modern source control and set up a CI/CD pipeline immediately. Even if it just runs a build, you've centralized that process.
Get it off one person's machine.
Yes. And then you containerize or script the build. Make it 100% reproducible by anyone on the team. That's step one.
Okay, what's next?
The safety net. You probably can't write thousands of unit tests in 90 days, so you add system and golden master tests.
Can you explain what a golden master test is for anyone who hasn't heard that term?
Sure, it's a really pragmatic approach. You run the current working system with a specific input, and you capture the entire output. You save it. That's your golden master.
The known good result.
Exactly. The test then just checks that for the same input, the new version of the code produces the exact same output. Doesn't prove correctness, but it's an incredible tool for catching unexpected regressions. It tells you instantly if your change broke something somewhere else.
That sounds like it would immediately reduce the fear of making changes.
It does, massively. While that's happening, you document the absolute essentials architecture diagrams, run books for common issues, and then you start the cultural part. Rotate developers right away and make sure every single deployment uses future flags and canary rollouts to minimize risk.
Fantastic. So those are the quick wins. Let's zoom out to the long-term view. Incremental modernization. Incremental modernization. You have to start making the code itself healthier at some point.
Right. You move from fixing the process to fixing the product. It starts with a mindset, the old Boy Scout rule. Always leave the code a little better than you found it. But the real strategy is like renovating a building while people are still living in it.
I like that analogy.
The system has to stay online, but you start updating one component at a time. And the key to doing this safely is using something called an anti-corruption layer.
An anti-corruption layer. That sounds intense. What is that, practically?
It's basically a translator. Imagine your old legacy system speaks ancient Greek, and your new front end speaks Spanish. Instead of teaching the new code ancient Greek, you build a small API in the middle that translates. It protects the new, clean code from all the weirdness and complexity of the old code. It stops the corruption from spreading.
And organizationally, how do you structure the teams for that kind of long-term work?
You've got two main models. Either hybrid teams, where a little bit of maintenance and modernization is just part of every team's job, or you create dedicated squads and you give them a prestigious name like the Core Systems Guardians or something. You make it a high-status, critical job, not a punishment.
Here's where it gets really interesting for me. We're talking about all this manual effort, but how is AI starting to change this game? How is it helping to lift this burden?
Oh, it's a total game changer, and it's happening in three main ways. First is just basic code understanding and documentation. You can take a 30-year-old file of code, feed it to a tool like GitHub Copilot Chat or SourceGraph Cody, and just ask it, what does this do?
And it will tell you.
In plain English, it can map data flows, explain the business logic. It cuts down that initial what on earth am I looking at phase from weeks to hours.
Wow.
Second, AI is incredible for test generation. For systems with zero tests, tools like DiffBlue for Java can analyze the code and automatically generate a huge suite of unit tests. It builds that safety net for you, and much faster than a human ever could.
And the third area?
The third is full-on code migration. We're seeing tools like Open Rewrite or new AI agents like Codebase that can automatically document, refactor, and even start redesigning entire systems. They can find and fix common patterns of technical debt across 1 million lines of code. It's not magic. You still need an engineer to oversee it, but it turns a tedious manual job into a high-leverage strategic review.
It sounds like the definition of technical debt is changing. The barrier is becoming less about the code itself and more about the organizational willpower to actually do the work.
Exactly. The code debt is becoming solvable. It's the people debt, the knowledge silos. That's still the main threat.
So as we wrap this all up, let's look forward. For all the new software being built right now, how do you prevent it from becoming tomorrow's untouchable legacy system?
You have to be deliberate from day one. There's a checklist. First, design for change. That means modular architecture, clean interfaces, so you can swap out one piece without the whole thing collapsing.
And testing.
And testing. Automate tests early. It is the single best insurance policy you can buy against the future fear of change. And also, document your decisions, not just your code. Write down why you chose a technology. The code will change, but the reasoning behind it is invaluable.
What about just the natural decay of a system over time, the entropy?
You have to fight it actively. Keep dependencies current. Don't let them get 5 years out of date. Budget for those upgrades, and build with CI/CD from the very beginning. Automation is your best friend.
And the people side.
Share knowledge continuously, no silos. And finally, you have to actually measure and address technical debt as if it were a real item on your budget, because it is. It's a liability on your balance sheet, and you have to pay it down. And when you do all that, you're not just building good software, you're building an engineering culture where people feel safe and empowered and, proud of their work. It's a direct investment in keeping your best people.
We started this with the idea that legacy is a leadership problem. It sounds like the solution is really a leadership discipline. It's not a second-class task to be avoided.
Not at all. It's the foundation of everything. It's where the revenue comes from. And that really brings us to the final thought we want to leave you with. It's this: innovation only creates lasting value when it is built on stability. If that financial cornerstone is crumbling because nobody respects the work of maintaining it, then all the shiny new features you build on top are fragile. They're built on sand. Real lasting innovation is only possible when the core is strong.
Thank you for listening to the Agile Engineering Deep Dive podcast. If today's episode gave you new insight into working across teams or highlighted the role of discipline in achieving real agility, feel free to share it with your colleagues or your network. You can find the full written article along with previous episodes in the Agile Software Engineering newsletter on LinkedIn. And if you have thoughts, questions, or examples from your own organization, I'd be happy to hear from you. Your experiences help shape what we explore next. Thanks again for tuning in, and I'll see you in the next episode.